Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today I have brought a very interesting lead code problem, lead code 739, daily temperatures. This question has been asked by a lot of FAANG companies in their last 0 to 3 months of interviews. A few namely Amazon, which has asked it 10 times, Google 5 times, Meta 4 times, Microsoft 2 times, Apple 15 times. So it's a quite important question in terms of questions on stack or monotonically decreasing stacks. So let's see what does this question say and what would be the optimum way to solve this question with minimum use of time and space. You have been given an array of integers temperatures which represent the daily temperatures. You have to return in an answer an array itself where each index value in the answer represents the number of days it takes to go to a higher or a warmer temperature value. Every index value here in input is your temperature of the day. So if in future you do not have a day which has temperature greater than this temperature, current day's temperature, then you have to return a default value of 0 for that particular index. Let's walk you through a few examples to understand the question better. In example 1, you have been given this input value temperatures here as shown. And the output is this. How will we get this output? So your first value is 73. Now your next value is 74, which is greater than 73. So you found a higher temperature in just one index difference. So that's why this index value is 1 here. Now from 74, the next index value is 75. Again, the difference between the indices is 1 again. From 75 to the next value 71. 71 is less than 75, so this is not your answer. Then from 71, next value 69. Again, it's not an answer since it's less than 75. Next value is 72. Again, it's less than 75. But the next value 76 is greater than 75. So there is a difference of 4 indices. That's why your output has 4 here. Now your next index value after 75 is 71. For it, the next index value is 69, less than 71. Next value is 72, which is greater than 71. So you took 2 indices to reach a value greater than today's temperature. Now next index value is 69. Again, its next index value is 72, which is greater than 69. So it took only 1 index difference. From 72, next value is 76. Again, 1 index difference. From 76, the next value is 73, which is less than 76, and there is no more value. So there is no temperature or no day exists for which the temperature is greater than 76. Hence the value for that particular index is 0, and the value for next index is 0 as well, because there is no day which has value of temperature greater than 73. So I hope you understand the question well. You can try solving example 2 and 3 with the same brute force approach. Now, what was the brute force approach we used here? We basically went through the temperatures array once, and then with each index value for which we are looking for a higher temperature, we went through the remaining array again. So basically, it's a nested for loop which we are using, and the time complexity in such a scenario would be O of n squared, whereas your space complexity would be O of 1. Since you are going through the temperatures array again and again to find a temperature value greater than the current day's temperature. So you're looping through a for loop within a for loop. So I hope you understand the brute force approach. But can we do better than that approach? So the answer is yes, by using a monotonically decreasing stack. Now what do I mean by monotonically decreasing stack and how will I use it? Let's try solving it using example 1 itself. So I have my input temperatures depicted here. I have my output array here with all the zeros populated as default. And I have my stack here. In my stack, I will store the pairs of what would be the pairs I'll store temperature and index pairs, because I need the index as well to calculate the difference between current value and the index of future temperature which is greater than current temperature, and so on. So I will store temperature and index pairs rather than just temperatures. Now first value which I have in temperature is 73 and index is 0. So I will push it to my stack. Now my next value is 74, index is 1. I will compare 74 with the top of stack value which is currently 73. So 74 is greater than 73. So I'll calculate the difference between indices and update the output value which is 1 now, because index for 74 was 1, index for 73 was 0. So 1 minus 0, 1 got updated here. And I will pop this value from top of the stack and I will add the current value pair to the stack. The current value pair is 74, 1. Now I will go to the next value which is 75 and the index would be 2. So I will compare 75 value with the top of the stack value, which is 74. Again, 75 is greater than 74. So I'll calculate the difference between the indices, update it here, pop this value pair from the stack, and then I will add 75, 2 to the stack. Now my next value pair is 71, 3. Now I'll compare 71 with top of stack value 75, which is greater. So 75 is greater than 71. So in this case, our condition is not true. So we will add 71, 3 to the stack and will not pop anything or update the output. Now I'll go to the next index, which is 69, 4. That's the pair. Again, I'll compare this value with the top of stack value. Right now, the top of stack value would be 71, 3. 69 is again less than 71, not greater. So I will just add the 69, 4 to the stack and not pop anything. Now, next value is 72, 5. I'll compare 72 with top of stack value. Top of stack value right now is 69, 4. So 72 will be compared with 69 and 69 is less. So I will pop this and I'll calculate the difference between the indices and update the difference between indices here. And I will add 72, 5 here. Now I will also compare 72 with top of stack values before adding. And again 71 is less than that. So I will pop this up and I'll update the difference between indices here, which is 2. Now I'll compare 72 with 75. 75 was greater than 72. So it will not get updated. Index 2 value will not get updated. Now we'll go to the next index. It's 76, 6. I have been compared it with top of stack value, which is 72, 5. Now 76 is greater. So I can pop this up and I can update the value here as 1 because it took just one index. I will compare 76, 6 with 75, 2, which is the top of stack value. Again, 76 is greater than 75. So I will update this value by difference of indices, which would be 4. And I will add 76, 6 here. Now I will check for next value, which is 73, 7 and add it to the stack since 73 is less than 76 and there is no more input value. So these two values remain in the stack. And as you can see, every time we add a value to the stack, it is either in the monotonically decreasing order, the value of temperatures, or the temperature could be equal. Say suppose you have 73 here as well. Now 73 again is not greater than the prior temperature 73, it is equal. So it will also get added to the stack as 73, 8 and the value for it in the output will get updated as 0 as well. So the stack which you will use will always have monotonically decreasing temperatures or equal temperatures. So this is the approach I am going to take. The time complexity here would be O of n. The space complexity would also be of n because you are using a stack. Now let's see how will we code this. So I'll first initialize my results array. My result array will be initialized by zeros as default, as I did it in my example. And the number of zeros would be length of temperatures array because I need those many output index values, right? And I'll also initialize my stack as an empty stack. And this will have pairs. And what would be the pairs? The pairs would be temperature, index. Now I will enumerate through my temperatures array. So for index, temperature pairs, in enumerate temperatures, I will check while the stack is non-empty and the top of stack value is less than the current temperature. The top of stack value you can obtain by stack -1 and the temperature is at 0 index and 1 has the index value. So I will compare the temperatures and I will pop that value because the current temperature is greater than the top of stack temperature. So I will pop that value and assign it to stack T and stack index because it is temperature and index pair. So stack.pop. This is O of 1 operation. Now I will also update my result. So my result will get updated at stack index because that is the index which was at the top of stack. So I will update it and what will the value be with which I update? It's I current index minus stack index. Finally, I keep on doing this through the entire loop until stack is empty. And I will append the current value pair of temperature and index to the stack and I can return my result. The time complexity for this solution would be O of n. And the space complexity would also be O of n since I'm using a stack. Let me run it. It's accepted. Let's submit. So as you can see, our solution is doing quite well here. If you have any doubts, feel free to ask them in the comments here. I'll be happy to address it. I would suggest you pause this video, try understanding what was this monotonic stack approach which I use, because it can be transferred and used in several other questions as well. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.